Okay, so for 424, the idea here is that we want to estimate linear functions or estimate whether or not a linear function can fit a set of data or is a good fit for a set of data. Really, in order to do that, you're going to have to graph it, okay? And then we can use slope or whatever to figure out our equation, blah, blah, blah. So, pause these if you need them. Just a reminder of what slope is and all that good stuff. But let's jump right into an example. So a weather team records the weather each hour after sunrise one morning in May. The hours after sunrise and the temperatures in degrees Fahrenheit shown in the table below. So there's your table. Can the temperature 0 to 7 hours after sunrise be represented by a linear function? If yes, then write the equation of the function. So the first thing you want to do is you want to graph it, okay, which I've already done here. Now, is that a perfect linear function? No, it's not. It's a little bit off here and there. The question is, can it best be represented, right, by a linear function? In other words, would the linear function be the best fit for that data set? And if you look at it, that's pretty close to a straight line, right? It's pretty obvious to see that that would be a very good choice for the fit. And just sketching this line out here, something to that effect, right? Kind of goes right through the middle of all those data points. Now, it's not perfect, but we can pretty much, use it for what we need to. So the question is, what is the equation? What is the equation of that line? So the first thing we want to do is write down what points we have. So it looks like our line pretty well goes through, and I'll tell you this, depending upon what you choose as points will determine a little bit what your equation looks like. So I'm going to say it looks like mine goes through 0, 52. Okay. And again, I could actually go back and look because I pulled that one from the previous page. So 0, 52 was indeed that first point. And then it also goes through a point up here. Goes through a point right there that we'll say is 664. Now, the reason that I want to use those two, and of course my line's a little off, but again, this is just we're just finding a good equation. We're not finding necessarily the perfect equation. So I know my y-intercept is 52, and then to do slope, 64 minus 52 over 6 minus 0. And so that is 12 over 6, which means that this is 2 for my slope. So y equals 2x plus 52. And again, that's just a good representation, a good linear function to represent that data set, which would help you predict other values in the future. Okay? Now, whoops. Get that pulled back up. Now, what happens if it's, not a perfect fit? What would be your best bet there? And so what we want to do now is look at a different example where maybe it doesn't fit so well. So if we look at this next one, here's the data, and you can read through the problem. But again, the first thing you want to do, step one, is going to be to graph that. So I've already kind of graphed it for you here. It's already been graphed for us here. So now we want to look at, does a linear function fit this data? So if I'm kind of looking at that, I'm kind of thinking I want some above and some below, right? Think back to what you read in that residual page. And you end up with something like this. Here's what I want you to see. We know certain types of functions. We know linear, we know exponential. Okay, and then there's other ones too that we can learn about later. But my point is, if you think about this one, if I were to follow these dots, definitely appears to be representing some sort of curve more so than linear. Okay? And when that happens, then you don't really have anything to do here. You're going to say, no, a linear function is not the best representation for this data because it doesn't appear to go in a straight line. It appears to go in a curved line. Okay? So in a problem like that, you're not going to do any work beyond graphing it and determining that it's not a good fit. Okay? So moving on to the example 3. Automated traders can mow lawns without being driven by a person, blah, blah, blah. Keep going through the problem. Again, here's your data set. What do I want to do? I want to graph it. Okay? So It's already been grabbed for us. Now, does that appear to be a curve or a linear function? In my mind, when I look at it, I see a linear function. Okay, I got points above, points below, right? It's kind of right in the middle of the data. I may not draw a perfect straight line, but I tried. And so then the next thing you want to do is say, okay, well, if that's my line, let me see if I can find some points that are on that line. And, we can look. Mine appears to have gone through like 0, 5 maybe, or 0, 0. I can't tell. It looks like 0, 0 right here. Okay, so we'll use 0, 0 as one of our points because it's pretty close. And then for another point, kind of nice, neat along the way here. I didn't go all the way to that top point, 4112. So the ones in your notes are actually going to look a little different from mine because mine's a little off. I did appear to go through this point right here, which is 3590. So that's what I'm going to use because that's what my line went through. If your line went through something different, but it was close, then it should have a similar slope and a similar y-intercept. It should be relatively close. It don't have to be perfect, but it should be relatively close. Okay. So, again, as long as it's a decent fit for the data, that's all you really care about for this. So, what do we end up with here? We end up with 90 over 35, because you got 90 minus 0 and 35 minus 0. And then that comes out to, let's see real quick, 90 divided by 35 is 2.57. So y equals 2.57x. Okay, now that's how you would do it by hand. I will show you in another video, which I'll add later, because I want you to have to do some of them by hand first. I will show you a way that we can actually calculate the best fit equation using your calculator. So stay tuned for that. But for now, in class today, we're working on 423 and 424. Okay? All right, thanks, guys.